These aren't celestial, but oceans does include some trig problems with lights. So I'm going to put both 50807, course to steer to pass a beam of the light, and 50891, special case bearing, in this problem. 50807. While on a course of 283 degrees per gyro compass, a light bears 10 degrees on the port bow at a distance of 8.3 miles. What course to steer to pass 3.5 miles, a beam of the light leaving it to port? I draw a line from the ship to the light, 8.3 miles. It bears 10 degrees on the port bow right now, but that doesn't really matter. What does matter is that we'll have our new course at the right angle, comes off of that new course and goes to the light. And that opposite side will have a length of 3.5 miles. So this will be our new relative bearing. Our opposite is 3.5, our hypotenuse is 8.3. So r equals sine to the -1 of 3.5 over 8.3. Equals 24.94 nautical miles. No, degrees. Whoops. We already have it 10 degrees on the port bow, so we just need to get 15 degrees more. So to make something be more port, we turn more right, so we add 15 degrees to 283 to get new course of 298 degrees true. Next, the special case bearing with the law of sines. Problem 50891. We have our ship's track. We have a DR. We have 0317. We have 0342. Our speed is 14 knots. 42 minus 17 over 60 times 14. This distance is 5.83 miles. We're steering 354 and we see a light at 49. And I make this plot with relative bearings. +49 plus 360 minus 354 gives me 55 here, and 71 plus 360 minus 354 gives me 77 here. Because of complementary angles, this is always 180 minus whatever this angle is, so in this case 103. And because of the rules for the inside of angles, the rules for the sums are the angles inside of a triangle, this will always be 180 minus this, but it's also conveniently the difference between 77 and 55, the difference between our second bearing and our first bearing, so that one is 22. The distance h of our right triangle from our second bearing to our light with the law of sines is always this. H equals D times the sine of the angle A over the sine of B minus A. So in this case, H equals 5.83 times the sine 55 over the sine of 22. The distance h is 12.6 nautical miles, and that's the hypotenuse of this right triangle. So to get my distance when a beam, here is my theta, there is my opposite. So A equals h sine lowercase b, b equals h cos lowercase b, and A will give me my distance when a beam. So all I have to do is take the number on my calculator, multiply it by 77 sine to get 12.4 nautical miles. My answer is B.